of Numpy and Pandas in some real world situation or a real world use case, like how Numpy is used or and Pandas is used. Okay, and after seeing the use case of both, then we will be covering some topic that we left yesterday. One was the one hot encoding, and the another was handling missing value, like filling the missing values with zeros or any arbitrary value, like or any you can replace with any placeholder value or with mean median mode. Okay, so we'll be seeing that. Okay, so starting with the thing that like Numpy and Pandas. So I have already taken an example of in here. So where we will be using our Numpy, that is for basically for image processing purpose. Okay, so basically here I have a image untitled GPG. So this is the image basically. Okay, the raw image file. So I will try to convert this image into black and white or grayscale using Numpy. Okay, so basically using this image processing, let me open our yeah. So using this Numpy library, you can perform many real world use case. Okay, so let's take an example of image processing. In image processing, what techniques or what step you have mostly, like, okay, so like you can perform a task like cropping the image. Okay, so what basically an image is? So image is like your pixels, right? So image is created with your like some pixels. Okay, so the intersection of pixel, like if you have seen, like you have 720p. Okay, so that means on an inch how many pixels are there, and the number of pixels are higher, the better the quality of your image will be. So if you watch a video on 144p, the quality will be lower. Okay, so basically this is made up of this pixels. Okay, so the pixels are the small boxes that represent the color, like this box will represent red color, and this will represent also red, and this will represent black, or and this will represent red. So this is how, when you combine these all these boxes, you get image something like this. Okay, so if you will zoom this, so this is created of pixels. Okay, so if you see here, the if you will zoom it more, if you will see in this particular area only, we will be having some huge number of pixels. Okay, so if I show you pixels in image, so what Numpy does is, if I get any image, pixelated image, so you see this, right? So this A, P and 8 is created out of these boxes, right? So some are the white boxes and some are the black boxes. Okay, so how they are defined? Okay, so you can in Numpy, yes, yeah, any doubt?
Actually, your voice is
Okay,
it was flickering. Can you go back one more time? I mean, you are saying like 720. I mean 144 is plus quality. That's what I have.
Okay, okay.
Yeah, 144.
So yes, so basically this is these are the number of boxes, right? 144 boxes per inch. I don't I'm not aware of particular. I think it is of per inch. Okay, so basically it is like your in a certain amount of area, how many number of pixels are there. If there are 144, so there will be 144 number of these boxes, and if it is 720, so there will be 720 pixels in that particular area. So how many the number when the number of these pixels increases, your quality of your image also increase, right? So if you see this image, this is built out of pixels, right? So this, since this is of a lower quality, you can see some pixels, right? You may see some distortion here, like you may see some pixelated image, right? So if you see these pixels, these are the pixels, right? Here you see white boxes and black boxes. So how they are denoted is between the in a colored image, these are represented, the colors of these boxes are represented with values between 0 to 256.
Okay.
Okay, so like mostly the white color is denoted with 0 and your black will be denoted with 1. Okay, so like this your image is displayed. So wherever you will see this white boxes, the numerical or the data that will be stored in here will be 1. So this box contains the data that is 1, and this box contains the data that is this contains 0 and this contain 1. Okay, and how it is displayed is basically it will be a grid of a matrix, right? If you have if you are aware of the topic like matrix, so using that this image is displayed. Like on this first column, this is 1 comma 1, okay, and this is your 1 comma 2. So similarly this will be like something 10 comma 16, and we will say in 10 comma 16 there is a box. In that box value we have 1 value, okay, and our model or our code knows that 1 stands for black. So it will process that data and will display you the image. So this is how your image is built. Okay, so what we will try to do is we will try to take that matrix of numbers. So it is basically like this matrix of numbers. In this contains somewhere 1 0 1 0 0 0 0 1 1 0 0 0. So this image will look something like this. So whenever you will see this 0, so it will be white space, and wherever you will be seeing this 1, it will be your black space, black thing. Okay, this
That's the default one.
yes, like most of the time it is used, but if you want you can change these values. So this image will look something like this. Okay, so this is a very basic example. Okay, so if you will do a project that is your hand digit recognition, in that project basically you try to recognize the handwriting, handwriting recognition, right? So in that basically you use these step to recognize your image and create a matrix out of it. So this image will return a matrix something like this, this matrix. Okay, and now we have got our image into numerical form. Now we can do some mathematical computation in it and do some machine learning model, apply some algorithms in it. Okay, and so using this numpy we can perform image processing, right? And we can crop our image, we can resize our image, you can apply filters. Like you have seen some Snapchat, right? You might have used or you have seen the Snapchat filters. So you can apply those using this numpy. But how they basically those filter works, right? So those filters are trained such that it will identify the pattern that is that represent your eyes, right? So it will try to find the pattern. So this is a pattern, right? Basically you see here we are having 1 1 1. So this is a pattern that draws something like this, this, right? So similarly we have a pattern for eyes, right? So it will be something like this. If I to draw a matrix for it, for a face, this will be your face, right? So your colored boxes will be like this, right? And if your model finds this pattern on your image, right, and other values will be 0 or any other values, right, ranging from 0 to 256 for colored image. Okay, so if your model find this pattern, it will apply some filters, or it will apply some it will highlight those area for your eyes. And similarly for nose, suppose you have another value like 2, right? Your nose will have some other color pattern, right? So it will look something like this. So it will find a pattern like this, and if it says that here there is a nose and here it's an eyes, so it will take that filter and it will add to your image, right? The main process here is to identify where your image, your eye, your nose are located. Once you have located where your object is, like here we are dealing with eyes and nose, once you have identify where they are, now it will be easier for you to filter, apply the filter on it. Like your filter will be already trained that wherever you see the eye or nose, wherever you are given the eye or nose, apply this thing, or you do highlight this, or make them broader, make the eyes broader, or whatever you want to do, add glitters, right? So the main thing was to identify where your eyes and nose are located. So using this technique, this matrix, creating a matrix out of your image and finding the pattern, right? So this will be your machine learning model. Your machine learning model will be given with thousands or lakhs of already seen image and the matrix of it. Okay, then it will try to figure out which pattern is for eyes. Like it will be also specified that this image contains eyes at this particular position, or it will try to learn it by seeing different images. And once it get the idea of what the pattern for eye looks something like that, it will denote it on a, it will, so that if whenever you give a new data or new image to it, it will be giving a name to it, or it will be specifying that this pattern is for eyes or nose. Okay, so therefore, yeah, so yeah, please say.
Basically, imaging from the image, machine learning convert as a matrix. From the matrix, we have to find out the
patterns.
From the pattern, we are using filter.
Yes. So then you can apply. So you can use, yeah. Then you can use your filter, or you can crop the image or resize the image. Then whatever you want to do. Okay. So this is a particular basic fundamental or background of it. In the background.
Pattern, we are using all the.
Yes, like from the pattern you are identifying where your eyes are located, where your nose are located, right? So yes. Yes, so I'm giving some this time in the theoretical time, because if on a code you will see that we are writing just one line of code and it is performing all the task on the backend, right? So there is no need of understanding there. So most of the time you have to spend is on the theoretical stuff. Yeah, right? Yeah, please say. Any doubt?
But it's totally a different when you. Yeah. Can you hear me?
Yes, please say.
Yeah. So the thing what I am trying to say is, what I am trying to say is, see, if you read any document or tutorial, it's totally different to the real thing. Say, as you said, like if you read a matrix or pattern, I'm confused now. I got clear picture.
Yeah. So that is the important thing, that you should have a clear picture or clear understanding of how the things are working on the back end. right? So yes, let's keep it till here for NumPy library, and let's do some practical implementation of it, right? So let's import the NumPy library, and we have since we want to perform the operation on our image, there is another library, that is your PIL. Okay, so it will help us to perform, it will help to basically read this image format. Okay, so with help of this PIL library, we have a module that is image. So we are using this image and opening this file, that is your untitled.jpg. Okay, so here this file is placed. Okay, so and we have created an array of it, right? You see, if I print this, the matrix, right? If I will print this image here, so you see this matrix is printed. It will be ranging from 0 to 256 to 265. Okay, so these, since this is a colored value, right? So this is a colored image, so this will range from 0 to 256, right? But if it but we don't want to do perform a computation on our colored image, because most of the time we will be converting it into a black and white image. Why? Because your colored image is computationally expensive, right? You see, whenever we want to perform any operation on our colored image, can you hear me properly? Means voice is clear?
Yeah.
Okay. Okay, so whenever you are performing operation with this colored image, you have to do computation on these numbers, right? It will range from 0 to 256, but it could be computationally expensive, because since these are matrices, so you may see how many values are there. Okay, and for every calculation, like we want to do any computation, so these whole array will be got executed, and it will be a whole lengthy process, and it will give a huge it will take a huge time, right? Just for computing for one image. And while machine learning, we will be having lakhs of such images, and then it will take like days or not months, right? Months, and sometimes it takes years to train our image and data. Okay, so like you have seen DAL-E, right? That image generator, right? So that's why it is like it takes you credits, like it is not free like ChatGPT, because this image thing is more computationally expensive. Like you can use ChatGPT for free, but you cannot use that image processing thing for free for larger time. Okay, so that's why the most of the time we have to convert that image into grayscale, or you may say black and white. Okay, so here with the help of this NumPy library, right? NumPy for numerical calculation, we are using a function that is dot. Okay, so what this dot does is it will convert your image, that is your colored image, into black and white or grayscale, right? So this was your image, original image that we have load here, right? Image here, and here we are specifying that take this whole list, right? And replace all the values with these three values, these three, right? 0.29 and these values. Okay, and now you have an now you just want to take this PIL library, this image module, and you want to save it on your local drive. Okay, so here I am giving it a name as a grayscale underscore image.jpg, so it will be saved on my local storage. Okay, so in this we have a from array. This was an array, right? Now what earlier we did was we took the image, this image, and we converted into a matrix or array, right?
Yeah.
Now what we are doing here is we are converting this array and now we are converting from this array to the image. Okay,
Yeah.
from array we are converting into an image and then saving it, right, and giving it a name. Okay, so if I run this, it will be executed, right, perfectly. If you see the output, this was the output.
Yeah.
This is your black and white grayscale. Okay, so this is just created with these three values.
Yeah.
These three values, this, and this. Earlier you have seen that there were many, like
Yes.
0 to,
These
yeah.
are the,
These are the values.
these are default value. These
No, you may change.
are,
You may change them.
yeah, values are default or
No, you may change them. Like if I want to just try it. I don't know if it will work fine or not, but let's just try it. Okay. If I do make some changes on it, let's see what do we get. We are getting some values change.
yeah.
Okay.
Yeah, that is fine.
So yes, so you have to take those some values on consideration. The, like, you cannot, means there would be some rule. Okay, so you have to do try and test it. Okay, so for most of the time this code will work to convert your black and white image. Okay, like
Hold on. Hold on.
yes,
Hold on.
sure.
One
Yeah. Okay, no problem. So you can see the screen, right? Okay, so yes, so you may take some other images as well. Like if I to take another image, if I take any image from internet, like I take this image or any colorful image, this image, and I save it on my local storage. Let us give this name as untitled 1.jpg, and I give to our code, right? So this image will be saved here, right? Untitled 1.jpg. Okay, so if I give this image to our code, to our this numpy snippet, so it will generate and create it should work properly, right? Grayscale underscore image, right? So this is how you can convert your image into black and white. Okay, so any doubt in this code, like till here?
No, I'm good. Yeah.
Okay, so and another thing that you can do is you can create some data also using this numpy module or numpy library. Okay, so there's a function that is random, and it will give you some random values. Okay, and you can it will give you some random values, and you can normalize it. Okay, and you can store data in your normalized underscore data variable. Okay, so using this np.mean, it will give you the mean value of your data set. Okay, so this was our data here. This was a randomly generated 100 numbers. Okay, so we are subtracting our data from the mean value. Okay, so the mean value will be replaced, and it will be subtracted with this data value. Okay, and it is divided by your standard deviation, but that value, the standard deviation of that value, right? So this is your formula of finding your normalized data. Okay, so this is how you can use your numpy library for your data preparation as well. Okay, like basically for normalizing your data. Okay, After this we will start with pandas. Okay, so you may see this, now this is your normalized data, so it will be basically 100 values that were randomly generated. Okay, so if you don't have any doubt till here, let's start with the pandas. Okay,
Yeah.
so I will be sending you this notebook. If whenever I forgot to share some notebook, please let me know. Okay,
Sure.
so okay, so here what we are doing is we are using pandas library. Okay, hope you have got the understanding of how numpy, why numpy is used and how it is important to us. Okay, now we will see how pandas is important. Okay, so basically in pandas, first of all we will how we will be dealing with pandas is we will be getting some dummy data. Okay, we will take some dummy data, we will not import it, we will be just creating it in on our code itself. Okay, on our dictionary. Okay, so okay, so here we have created a dictionary, right, and here itself we have specified the values. Okay, so there are four columns: name, age, city and salary. Okay, so inside these columns we have first Alice row, second row, third row, fourth row, fifth row. Okay, so the values are for the 5 rows as well. Okay, so for Alice, age will be 25, city will be New York, salary will be 60,000. Okay, so similarly for other variables as well. Okay, so we have taken a dummy data and we will try to perform some, first we will try to basically filter our data. Okay, we will be selecting some specific rows based on a condition. Okay, we will select a specific row based on condition. Okay, then we will be aggregating and grouping the values, calculating the mean salary for each city. Okay, like aggregation and grouping. Okay, so we will calculate the mean salary for each city, like for like this here the cities are different, but if like some cities are repeating, right, so we will try to group them, like the New York, there are 2 people from New York, right, so it will try to group them. Okay, so the 2 people from New York will be grouped together and their mean of their salary will be displayed. Okay, so we'll try that doing here, like aggregating and grouping, and after that we will be adding a new column. We will see how to adding a new column using pandas, and then using our with our existing data set. Okay, and then we will sorting our data, okay, sorting the data frame based on a specific column. Okay, like your age or whatever. Okay, then we will see how you can merge your data frame. Okay, like combining information from 2 data frames based on some common column. Okay, now let us start with the creating our data frame. Okay, so here we have used a simple dictionary here. These are the dictionaries, the basically your key value pair. So these are your key, and separated with the colon, these are your values. Okay, and this is your first element and this is your second element. Okay, your second element is separated with this comma. Okay, so this is the another key. So these are the keys basically. Okay, so we have got the data, we have got our data, and now we will convert this data. Earlier it was a dictionary object, now using this PD we are creating it as a data frame. Okay, in Python or in this pandas we call a data set as a data frame. Okay, like the collection of columns and rows as a data frame. Okay, so we have created a data frame object. Okay, now using this you can display your data. Okay, so this is your original data, right? Remember that this is your original data. This is your name of your column, and these are your 5 records, observation. Okay, or row. Okay, so sometimes we call it as an observation. Okay, sometimes we call it as a row, or okay, so observation is the same thing. Okay, so let's start with the first thing, that is your filtering our data. Okay, so we will give it a condition that we have an column that is age. Okay, and in this age we have some value like 25, 30, 22, 35, 28. Okay, and we will give a condition that if, okay, if the age is smaller than 30, okay, so it will be stored inside your another data frame, that is your young employees. Okay, okay, so here we are printing that particular data frame. Okay, so it basically does what is it is checking for this, for the values, the values of our every observation is smaller than 30, it will be stored in your new data frame. Okay, once I run this, now you see all the values are filtered. So this was our original data set. Here we are applying a filter, or we are checking, and once our filtering got done, you see those there are the new values. Okay, so this is pretty straightforward. Okay, you may try to play with it, like you can give it some other values, like you can specify some salary here and say salary greater than 55,000 or salary greater than 60,000, or senior engineer or whatever, and you can specify it here. Okay, you can try to do that. Okay, and now taking the another example is your aggregation and grouping. Okay, like you can aggregate by city, and like and then you can find the salary, their salary, and then you can perform some computation, like you can find the mean of it. Okay, so here what exactly we are doing it. Okay, so we are saying group by city. First of all, you have to group them all, this data, by city name. Okay, so since here all the city name is say different, so but if the city name would be different, like New York, but it would be twice, so it will group them, group those observation. Okay, so all the city with the all the cities will be grouped together. Okay, and then what it will be it would be doing is it would be taking the salary value, right, the salary for New York, all the salary for New York, people who live in New York. Okay, and it will try to find the mean of them. Okay, and here we are displaying it. Okay, if you see them, the value will be exactly same as here. Okay, because what will be the mean of 60,000? The mean of 60,000 will be 60,000 itself. Okay, because it is a one value, and average of one value is itself the value itself. Okay, so the values will be the same as here. Okay, so if you see here, you're in New York 60,000, San Francisco 80,000, Los Angeles 55,000, right? We have got some values like this. Okay, so what we have done is here we have aggregated and we have done grouping of them. Okay, so basically first you have to group them. Here you can group them by any column name. You can do grouping with the name of age also, like people with same age will be grouped together, and then you can find the mean of their salary, and you can say that the people with this age have mean salary of this much. Okay, people of this age will have the salary of this much. Like if there are people with 18-year-old, so you will combine all the 18-year-old people and will try to find their salary, and then you can say that the mean, the average of those people who have the age like 18 have this salary. Okay, so you can perform that thing with this exactly this same code. Here you will be specifying the column that you want to group by, and here you will be saying which value, for which value you want to find the mean of it. Okay, and then you are storing it on a new variable. Okay, any confusion or doubt till here?
No, I'm good. Yeah.
Okay, so taking a third example, that was your adding a new column. Okay, so suppose say you want to take this data and create some another insights out of it and store it the output on this in the same value. Okay, suppose say you want to give some bonus. Okay, so you want to give some like 0.5% bonus to every suppose say 2% bonus to every employee. Okay, so what you will be doing is you will be creating a new column, and inside that column you will be multiplying your value will be 0.2 sorry 0.02. Okay, so 0.002 will be a 2% value. Okay, so that will be multiplied with this value and will be stored in a new column. Okay, so that is how we can try to do here. Okay, so here we are taking an example of salary adjusted. Okay, so here it will so basically we are giving increment of 10% to every employee from their older salary. Okay,
Yeah.
from their previous salary. So how we are doing is we can just simply multiply the we can say df. Inside this df we can take square brackets, and in square brackets we have to specify the name of this particular column. Okay,
Mm.
and then we have to give the you can perform the computation here. Okay, or the operation here,
Mm.
and then you are storing it on a new variable. Remember, here you don't have to have already the column name here. Okay, you can just give any column name here and it will be created by itself. Like salary underscore adjust is what was never created earlier. Okay,
Mm.
so it was just created here, and at the same time the values from this was stored in here. Okay, and now here we are displaying the particular this exact same data frame. Okay, so all the values from this salary will be multiplied with 1.1 and it will be stored in your salary adjusted. Okay,
Mhm.
so this is how your pandas have performed all the functions. Okay, so if you remember here, if you would have a doubt that here where are we using pandas, right?
Mhm.
Actually, if you see this df, it is your pandas data frame object. Okay,
Yes. Yeah.
so this is your exactly your pandas. Okay,
Yes, sir.
so this thing you can do in your pandas using, you can create a new column and you can store some values in it. Okay, and then taking off with example 4, here you can do what you can do is you can sort your values. Okay, like here you are having age column, now you can perform sorting and it will arrange your values by age. Okay, so inside this df data frame, your function that is your sort values. Okay, sort underscore values. Okay, so it has some parameters like ascending. Okay, so here you have to pass true or false. Like ascending, do you want the values to be sorted in ascending order or descending order? False for descending order and true for ascending order. Okay, and this value will be your which column do you want to perform this sorting. Okay, and now here we are just printing the output of this line. Okay, so your values are sorted in your descending order because here we have specified false. Okay, so this is your descending order. The third row, the fourth row is here, second row is here, fifth row is here, first row is here, and the third row is at last. Okay, so this has sorted by age. Okay, so that's it, that's all for sorting. There are some other function also that you can try on Google and try on working it, like what are some other parameters that you can use with sort, and like you can sort for categorical variables, and you can try it on your own, okay, like by reading some articles as well, okay. Now at last, just do this merging data frame, and then we will be completing our numpy and pandas, okay. So what we are doing in example 5 is we are taking a data frame, okay, and we are creating a new data frame, that is your additional data, and the data set from this data will be merged or added to your original data set, okay. So this was your original data set, and now here we are creating some additional data. So this additional data will be stored, this new column will be stored at the end of this, in this data frame, this original data frame, okay. So how we'll be doing it, we'll be using this name column, right, the common column for this merging data frame, okay. So this name will be our common column that will help us to merge the data set, okay, data frame. So we have created a dictionary here, and the same as step as we have used earlier, we are creating this dictionary as a data frame object here, and now using a merge function or method that is inside your pandas library, and inside you have to give the two data frame that you want to merge, okay. So this is your original data frame, and this is your additional data, okay, that you want to merge on your original data set, okay. And now here you have two parameters, that is on and how, okay. So on will be your column name, on the basis of which will be your common column, okay. So this will be your common column. So in on parameter you will be passing your common column, okay. So on this basis of this, it will be appended to it, okay. And this how parameter will be basically how you want to add your data, like, okay. So here we want to add on the left. So if you see it, it will be added to the left side, okay.
Okay. So
like the Alice here. So Alice was this Alice New York and 60,000. So this Alice New York 60,000 and have hobby reading, okay. So as specified here, Alice have reading, Bob has cycling, Charlie have painting, okay. Bob have cycling and Charlie have painting, okay. So now we got two missing values here, okay. So the value that we haven't passed here, so those value got as a nan, or we can say not, or we can say not a number,
not a number, okay.
okay. So we have, so now we want some technique that we can replace these values, okay. Okay, so that's it for this pandas examples. Hope this is also clear to you. Any doubt till here? Yeah.
Yeah, this one I'm fine. Actually, yesterday we were watching.
Yes.
I mean, we use one file, whichever located in our local, right? Can we connect from the database to get the file or data set? In the real scenario, we can get it like, I mean, do we need to connect data?
Yes.
Can we connect? Yeah.
Haven't I given you the data set? Means I would be having.
No, we got. Yeah, we received file from our local, right? So my question is, in the future, or if the data set is large, can we connect directly to the database, like Redis or something?
Yes. So basically, if I to give you an example, like how you will connect your data, like your data will be like mostly in your JSON format, okay. So
So JSON format in the sense only it comes in the file format, not in the table, right?
yes.
I mean, in not connect. Okay.
Okay, so in this format, like, okay, like in the ingredients you see here, and in your API format, and here you can see, here we are using database, right? SQL.
Yeah.
This I think this was your question, right?
Yes, correct. Yeah.
So we have a module here, like that is a mysql.connector. Okay, so it basically helps you to read your database. Okay, so you should have your access to your database. It should be have you should know the host, username, password, and your database name. Okay, and then you can read your using your queries, you can read your,
The data.
yes, now you can read your data and store it on a data frame.
Data. Okay, now I got it.
Okay,
Yeah. 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 Thank you.
okay, no problem. So this is how you can take your data. Okay, so if you have your data on your database. Okay, and okay, so now I think we have some time, so if it would be fine if the today's class will be like 30 minutes longer than usual, or you, or we should.
No. Yeah. I have another thing on. Yeah. 10 o'clock.
Okay,
Yeah.
okay, okay, like means we can do for how much, can we do for 20 minutes, like means what would
Yeah.
be the
20 minutes. Yeah. I think.
yeah, yeah, please check, let me know so
Yeah.
that
Yeah.
I can
You
start.
want 10:30. Yeah. We can go ahead 30 minutes as well.
Okay, like 30 minutes,
Yeah. You
right?
want to finish? 30 minutes more than that. That's fine. Yeah.
Means
If
30
you.
minutes
Yeah.
from now, right?
Yeah. Now, even if you go extra 10 minutes also, I am fine.
Okay, so then now we will see some imputation method. Okay, so imputation is basically filling your missing values. Okay, so let's just give me a 1 minute, let me have a water break, let me drink, then we'll continue it. Okay. So are you there? Your
Okay.
so your just voice is means like your mic is little bit vibrating, means it is means of buffering there.
Yeah. Now I connected to the mic. Is it good now?
Yes, now it's fine. Okay, so okay, so here we will be doing some like imputation method. Okay, so what your arbitrary value imputation basically is so we will be having a imputation. Okay, imputation method. Okay, so first topic here we have is arbitrary value imputation. Okay. So it is basically a method that is used for your handling the missing data, right, in your data set. Okay, so how we'll be doing is we will be replacing the missing values from like with some arbitrary chosen value, right. We can choose some values if you have some domain knowledge, as you have we have discussed on our first lecture, I guess. If you have domain knowledge, it's the best thing. Okay, so like if you have some already known information that if you have any missing value and you have some values that you want to replace it with, so that is the best case scenario. Okay, so uh, so you can replace that value with some your constant or your chosen value. Okay, unlike your like sophisticated imputation method that estimates missing values based upon like observed data, this arbitrary value imputation, basically it simply fills the missing value with any predetermined fixed value. Okay, so you have determined any fixed value and then you will be replacing the missing values with it. Okay, so here we have some common choices for our arbitrary values. That is like you can replace your values with 0, okay, or any specific number, or you can take any constant that will be outside of our observed data, that like choosing a value that is not present inside in the actual data to easily identify imputed value. Okay, so like so that you can, whenever you see your data, you can easily identify it. Okay, and then you can use some placeholder value. Okay, so like using a specific value to indicate that data is missing. Okay, like on by default it has some like it shows like nan, right, as you have seen. So like you can also change this value as like something like 999, so that you can see that yeah, that this value is missing. Okay, so but most of the time what we do is we don't take these values, and what we do is we try to fill those missing values with our mean value or mode value or median value. Okay, right. So how do we do this on our Python? Okay, using our pandas and other libraries. Okay, so that we will be seeing right now. Okay, so we will be first importing all the important or necessary libraries: pandas, numpy and matplotlib. Okay, then we have a sklearn or scikit-learn, okay, library that will help you to basically your splitting your data into test and training set. Okay, test and training set is actually the same thing that I explained you earlier on, like dividing your data on some like 70% or 30% for 70 for training, like you will be training your data, and on the 30% you will be testing or evaluating your performance of your model. Okay, and it has some it has some module for performing this exact thing. Okay, like simple imputer. Okay, and then another module here we are using, I think that will be not using right now. Okay, so we are taking a CSV file. Okay, and in this CSV file it is basically a cut down version of your Titanic dataset. Okay, the Titanic dataset as we have seen on earlier classes. Okay, so it just have the 4 rows, like the age column, sorry, 4 columns. Okay, the age column, fair column, the family column and the survived column. Okay, so like your survived will be your dependent variable. Okay, as discussed on the earlier classes. Okay, so basically your survived depends on these on the other values, right? Like fair, if your fair is high, the chances of a survival is high, because this passenger class is your will be your higher. Okay, and it also depends upon age, like sometimes, okay, like it may be or maybe not, okay. So basically your survived will be your output for your dependent variable. We will try to predict using our machine learning model. We will training our data and we'll be trying to predict the survive, whether the person is able to survive this thing or not, okay. And then we will test if the predicted value, the if the new value that was predicted was right or wrong, okay. So this, so just we are taking the 4 columns here for this particular imputation, and then we are just taking the information about this data frame, okay, like df.info, okay. So it will give some information about data, like data type, okay, like float value, age, it was float value, decimal values, fair is also decimal value, so float, family, and your survived is your integer value, okay. And here also it also shows that non-null values, like age is your 714 value, non-null, okay. So means this many values are filled, 714. Out of 891 entries, okay. So like your family and survived is completely filled, 891, 891, but there are some missing values for your age and for your fair, right. So now that we can see by doing the difference here, or just you can use a function that is your is null, okay, and you can find the mean of it. So it will give how many percentage of your data is basically unfilled, okay. So if you run this code, you will find that your 0% of your data is for family and survived. You may see this, and the 891 here is non-null, okay. But your we have some missing values for our age and for our fair, okay. So now we don't want to so now what we are basically doing is we are dividing in the next step we are separating our dependent variable, okay, that we want to predicted value, right, from the independent values or the features as I described, okay, because they are used to predict about this target value, okay. So we will separate those values. We will take these 3 columns as on another set, and this output set output or target or independent or predicted value on another column, okay. So here we are doing that step. On your x, it will be your independent value, the x will be your independent value, like these 3 columns, okay. So we are dropping the survived column here, okay. And in y there will be your this simple this column, okay, nothing else. So y will be your last column, okay. So now on x axis we have our independent variable, and in y we have our dependent variable, okay. And now we are using our train underscore test underscore split function, okay, that we have imported here, train test split, okay. And now we are giving it the data, okay. So independent value, dependent variable, and our test size 0.2, like means 80% and 20%, okay. Like our train will be 80% and test will be our 20%, okay. Same for x value and same for y value, okay. And this is a random state, you may just ignore this for a while. It will basically every time you run this code, your randomly this the value that will be 80% and 20%, it should be random, right. Not every time you run that train that model, not every time that 80% should be same, right. It should like mix them, like sometime the 20% value should come inside this 80% value values, right, okay. So then your values will be stored here in here, okay, x train and x test, okay. So this column is divided in 80-20%, and this column is also divided in 80-20%, okay, right. Now if you see the shape of them, your x train is basically your 20%, 80% data, right? So this is your 80% of the data, and x test is your 20% data test. Okay, so this is our 20% data. If you will add them up, it will be your 891. Okay, this and this, and since this is x value, so it is 3 column. Okay, if you will see for y, it will be 1. Okay, for y it will be 1 because in the y we have just survived. Okay, so if I run this, okay, now in a y train dot shape we have just one column. Okay, so it is just not displaying it because it's just a 1. Okay, if you do it x, it will be 3. Okay, so the our splitting of our data is completed here. Okay, now I want to see the missing values on my x train data set. Okay, so it contains this, our x train contains 712 values. Okay, so 712 values from these first 3 columns. Okay, these 3 columns: age, fair and family. Okay, because survived is inside our y column. Okay, so yes, so it is showing us the null values here. Okay, so like 20% of the value and 5% of the from fair. Okay, now what we are doing is yes, now we want to find the mean value, so we can do that by using this mean function. Okay, and then we are storing the values on our mean underscore age. Okay, so this is our this are the name of our column x train. X train is our data frame, and in this data frame we have this column age, and for this column, particularly this age that is inside our x train, we are finding the mean and then storing that mean in this mean underscore age. And similarly for median also, we are finding the median for this particular column age and then storing that in median underscore age. Okay, and same thing we are doing for fair also, and then storing it in mean underscore fair and median underscore fair. Okay, so if you do run it, yes, so if you run it, so your values are stored in it. Okay, so like inside your mean underscore age, your mean value is there. Okay, so similarly for other values as well. Okay, so if you print now the values here, okay, so now you can see that mean underscore age is this value. Okay, now you see if you see the output, mean of age is this, median of age is 28, mean of fair is this, and median of fair is this. Okay, just give me a second now. Okay, so yes, okay, so now we want to fill, so these values can be like a pretty best fit for our missing values. Okay, so like it will at least not hamper our data, right? Like if I would have taken any value at random, like for age I would have taken like 26, or I say 22. Okay, so that number may have impact on our data set. Okay, so that value may have impacted our this survived variable. Okay, so this taking this mean or median could be a better fit, and it would at least not improve, it would not at least hamper the accuracy of the data. Okay, so the chances of making it better are not that much, but still we are not it is not bad for our data. Okay, so we can replace the value with mean or median. Okay, so now how we can do that? Okay, so the thing here is we will be using a fill na method. Okay, that is inside your data frame. Okay, so this works for your single column. Okay, so here you have to specify the column name or the which particular column you want to see. Here if you see here, if you see there are just I am writing that in xtrain how many missing values are earlier, right? Right now these many values are missing values, right? So now I will store I will store a new not new but the same column, but this column will be different from the earlier. Okay, how it will be earlier? Because in this column now are all the na value, okay, will be replaced with this value. What was our mean underscore age? Mean underscore age was this 29.78. okay, oh yeah, median. Okay, median, yes. So this value will be replaced with 28.75. okay, for our age column. Okay, and it will be stored in the same column. You can if you want you can create a new variable like age underscore name new or any if you want, but for now I'm just keeping it same, okay, as the earlier column name. Okay, so if I run this, our age will be replaced with a median underscore age. There's this value, all the missing values will be replaced with this value, and for same for fair also it will be replaced with this 14 value. Okay, earlier you see here these many values were missing. Now if you will run this exact same code that was finding the is null and then mean it, now you see there are no null values. Okay, earlier there were missing values, now there is 0 missing values. Okay, similarly you can you can replace this missing values with any particular value as you want. Okay, if you want to replace it with 0, so you will specify here 0 or any specific number according to your domain knowledge, so you can specify it here, so all the missing value will be replaced here. Okay, like if you want to give a placeholder that to specify that this particular value is missing, you can give 99 also. Okay, so it will be replaced with your missing value, right? Hope you got till now.
Yes. Yeah. Here, see, for age, mean and median, there is not much a difference, right? So in this case, for fair,
Yes.
mean and median, there is a difference.
Yes.
36,
Yes.
right?
Yes.
So
Now,
36, how can we?
now here you have to check whether your while after applying this median, and then you will give your data to your algorithm, and you will basically try and test
Oh,
whether this value fits best or this value fits best, or you can do some graphing also before applying it to algorithm. You will give this value and you will perform graphs like this. Okay, you have some graphs like this. Okay, and if your value is not your according to your needs, then you will be using whichever value here. Okay, if you see here in the green line is your age underscore mean. Okay, and age underscore median is on your orange line. Okay, so this is particularly normally distributed. Okay, so what your normally distributed data is, it is basically it lies on the center, and your exactly 50% data lies on your right side and 50% of your data lies in the left side. Okay, So you get this value. Okay, so this is nicer to have. Okay, if you have, you can take insights by drawing just graphs, but most of the time you have to do perform algorithms, and you have to, by doing the manually, seeing how, what is the accuracy and is there any difference.
Oh, okay.
Okay, so like you can find the correlation here as well, like any values that lies near to +1 or -1 is highly correlated. Okay, so like if the value is near 1, that means it is highly positively correlated. If the value of age increase, definitely the age will be increased with the same ratio. Okay, and if the value is on minus, that means it is negatively correlated, means if the number of this value increases, the age decreases.
Yes, yeah.
Okay, so similarly for fare, so this is positively related, that means if age increases, the fare increases, right? As we have seen that the higher age people tends to take the VIP seat, or the higher class seat, right? That means the increased fare. Okay, so therefore you may see here that the 9% correlated. So this is how you can get the basic idea of your data. Okay, and the same thing like box plot as we did, and that's it for the mean median imputation. Okay, you can fill the missing values with it, and you can make it more complex, but for the basic fundamentals, this is it. Okay, now I think we should just stop it here, because this one hot encoding will take little bit longer. Okay, so can you hear me?